When it comes to cloud service threats, there are some outliers. What are those outliers? Stick around to find out.
You're watching IT Pro TV.
Hello, ladies and gentlemen. Thank you for tuning in again. We are continuing along the CySa Plus, and yes, we have talked over the past couple episodes about threats that specifically deal with cloud and the cloud services and architecture surrounding them. But I can tell you there's more that we got to talk about, some things that maybe sit on the fringe of cloud service threats. We're going to talk about things like function as a service. Dan, help us out with that.
Yeah, let's jump right in with the good one, right? Function as a service. This is really cool or fast. Also can be referred to as serverless architecture, or I've seen it as something else, but basically serverless architecture is one of the definitely a way to go with that. But what do we mean by that? You might not be familiar with this. It is more of a newer or prevailing technology that's starting to become more commonplace, but still, in my experience, it's still a bit of an esoteric thing. But it's really cool. Basically, what I'm saying is, instead of having to build a server, manage the operating system, put all the technologies that I'm going to need to create functions, right? I'm talking programmatic functions. I need you to do X, reach into this function, that function does X, okay? I would need to build that server. I would need to support the technologies, operating system, and so on and so forth. Whereas with function as a service, what I can do is just say, here's the code for that function. I'm going to put that in Amazon. I'm going to put that in Google. I'm going to put that here. I'm going to put that there. And when I need it, when I call that as a function, those cloud providers will spin up the infrastructure necessary, push that code onto it, make it available for your application to actually use it. It'll use it and then stop, right? So you're only paying for each, probably some storage because you're keeping that on or housing that information on their servers, but you're only paying for the use of the infrastructure as it's needed. So it can save you a ton of money. It can save you a lot of time and effort when it comes to management. So it's really nice. But as everything, as we've been talking about over and over and over again, everything has their threats associated with that. So let's talk about those. As I said, this is a bit of a newer technology, something that is starting to become more and more prevalent, but it's still, I would say, I wouldn't say in its infancy, but you don't see it as much as we will as it becomes more and more common. So it's got immature security around it. We're still figuring out ways to secure this up and do it correctly and create products and procedures, controls to wrap around that stuff. So you might find yourself with a lack of resources to help it keep it secure. So just keep that in mind. Customers at the mercy of the CSP's uptime. If you find a lax, and everybody goes through this from time to time. We've encountered that trying to create content here at IT Pro TV. You go to do a cloud show, and it's like, let's do some Azure stuff today. Oh, Azure's down in our area. We can't access Azure, right? So we were at the mercy of the CSP. You might find yourself in the same predicament when it comes to FAS. So it's just, again, part and parcel of the game when you're using cloud. You got to keep that in mind. Make sure if you need some critical functionality, that your service level will accommodate what you need out of it. And yeah, it's probably going to cost you a little bit more money, but ultimately in the long run, hopefully that works itself out monetarily, the juice being worth the squeeze, as it were. All right, compromised clients. So this is where it really starts to get into the security, something we can actually do something about. Because you're going to have a client machine that accesses this service to push functions. Okay, I want to create a function that does X, Y, or Z. Well, the developers are probably mostly the ones that are doing that, maybe some DevSecOps or whatever. But the developers are creating those functions, pushing them into your cloud service, and then there it sits. Now imagine if their host that they use was compromised, maybe through a targeted attack, something to that effect, and now they have access into your FAS. I can push, as a threat actor, push any function I want to do whatever I want because I have that access through those systems. So those systems are very important for us to make sure that they are hardened, make sure they are as fully hardened as they can possibly be, and no non-essential software or usage of those machines. So basically you want to create some systems that are designed and specifically for working with your FAS environments. Another thing will be, don't forget that these are devices that can access the code that you're running with. So I almost think of it as like a supply chain attack in that way, where if I was able to gain access to that as a threat actor, I could inject certain little functionality that would be beneficial for me. So the code itself is very important that we keep our eyes on, and the services that we are calling. So make sure that the services are as robust security-wise as humanly possible. But there you go. That's FAS and infrastructure and some of the threats associated with them to get you up to date and ready for the exam.
I know, when you have certain environments that you need, sometimes they can drift from here and there, and we want to stay consistent, right? That's one of the things, we got technologies out there like desired state configuration that make sure that our servers are in that state that we need. Tell me a little bit about this concept of infrastructure as a code, Dan. Now, this one here, I'm going to be learning myself. What is this about?
Actually, you probably already are aware of this. It's just you might not have seen it as labeled as such.
Sure.
Think orchestration.
Oh, okay.
Right?
Yeah. Absolutely.
Right. This is what
a lot of moving pieces.
Nailed it. So infrastructure as code, or IAC, is typically what we're talking about as some sort of orchestration. Now, this is great for us as an organization because, like Wes said, I get that consistency, right? And that's what we're looking for. We don't want those snowflake systems running around. We're trying to avoid that. And by snowflake system, I mean something that is configured in a way that's outside of what we would like it to be because of a mistake or, God forbid, a insider threat has come in and done something to it. But typically this is going to be done through mistakes or one-offs, right? We're trying to avoid those one-offs. I want a standardized way. Orchestration allows us to do that, to spin up machines or create services or do whatever in a way that is consistent across the board. We're looking for what they call, if I can say this, idempotency. That's our idempotency, which means that if I do the same thing in the same way with the same pieces, I should get the same result. And I want that across the board in my organization. That way I know exactly what I should be getting. If I get something that's off of that, we need to fix it. So that's what we're looking at when it comes to infrastructure as code. And again, I've already kind of let the cat out of the bag as far as the threats that go against this. This is going to be human error. If I am an admin, I can be the greatest admin on earth. I'm still going to make mistakes from time to time. Just part and parcel of being a human. But we want to avoid that. And using orchestration, programming, and doing things programmatically is always, that has been why we do a lot of that, is so that we can avoid repetitive tasks being botched because we made a mistake because it's becoming boring and repetitive. And my brain starts to wander. I can get away from that because now the machine just does it for me. I set it up one time. I say, if I need this, do it. So we can avoid those human errors. But that is a threat to that infrastructure as code. And of course, those insider threats, unfortunately, they do happen. You might think, oh, that seems like such a far. Nope. They happen all the time. People lack money and they get angry at their organization for whatever reason. And now maybe they feel pushed enough to gain a little money and a little payback at the same time. This happens often. We hate to see it when it does. We probably don't hear about it as often as we should because organizations don't like to reveal that kind of stuff has occurred. They keep that close to the vest so that their reputation isn't damaged and things of that nature. But it is a real threat because they already have that access and that trust necessary to gain entrance into those sensitive areas that they could cause a problem. So those are the problems that you might see if you're working with infrastructure as a code.
A lot of vendors allow us to interact with their product, their software, and one of the ways they do that is providing us with an application programming interface, right? You probably heard of this term many times, APIs, right? So Dan, I would ask, where do we have to worry about security, surrounding, various APIs that we're using in the cloud?
Yeah, we've got to secure APIs. APIs are an important part of business nowadays, and we can just start with an insecure connection. If I am using API and it's sending information, or the API is going across an unsecure connection, someone could reach out and grab it. Now they have the API. That's a bad thing sometimes, right? So you got to be aware of that. Always try to pass API information over a secure connection. Okay, because of that, it could make you susceptible to something like a man-in-the-middle attack, where I'm sitting in the middle, I've grabbed your API, and now I can make calls as a legitimate user and then you're going to send me the information that I'm looking for, maybe not necessarily what they're looking for. Okay, so and man-in-the-middle attacks are something you got to be on the lookout for because of that insecure connectivity. Injection attacks, I can inject code or I can inject commands through the API. I can also DOS, big deal, right? Denial of service. If I do a lot of API calls against your system, and when I say a lot, I mean like a lot, then your system can get overwhelmed with trying to service those API calls. And unfortunately, it could cause a DOS of that system. Now, you can mitigate that a bit with some like rate limiting or throttling. So if you have an API, you might want to look into that as far as like some mitigation against those types of DOS attacks that could be leveraged against your environments. Other things, debugging and errors that arise. I mean, we all deal with this, right? You got a cool application, or maybe you're working with an application, and when you're building it, you need all that information. Anytime something goes wrong, you need information about what happened. And this is where we go, where I feel like we're spinning around the circle yet again, because it's something we constantly have to reiterate, because we forget that if what I'm doing during the development cycle gets pushed out into the production cycle, well, then that could be a problem. Errors in debugging are a common way in which we see this, where I give away too much information through the errors that occur. Okay? So from that, you can maybe discern things like, oh, you used a bad username, right? That's an error that we got, right? You're trying to log in, authenticate, and you've got you used a bad username. That's a bad error. We shouldn't do that. What we should do is say, authentication failed. It doesn't tell you what was wrong, because you didn't say that the password was bad, just said the username was bad. And it's even worse when you say, well, you're doing the same thing if I just say, well, the user or the password was bad for that account. It said the username account was. I can start enumerating users for the system through the API because it has access into this authentication system, and we're giving too much information back out. So always be careful on what kind of debugging or error messages get pushed through your API, okay? Let's see here. Improper key management, probably one of the larger issues surrounding APIs. And this is something that we have to do as administrators of the system to try to bolster the security surrounds it. So think about this. If your code that you're working with for your application has the API embedded into it as you move across to make things easy, it's there, right? I didn't have to go through any kind of, if I were a user that wanted to get access to the API, because some people make APIs available, like Twitter. I can get a Twitter API as a developer, so I can create something that works with Twitter, okay? And I can have a Twitter feed going on in my web application because the API hooks into it. And that's fine. But if you have any kind of sensitive information that you're hooking into, and that API gives people access to that sensitive information, and you've embedded it into the system, well, now you're starting to see the problem, hopefully, right? Anybody that can see into that code would have access to the API and be able to write their own version of accessing that information, and now they've got keys to the kingdom. So it's an important thing. What the better thing to do would be is to store that API as a variable, so the variable gets called, right? So there's a bit of an intermediary between the end user and the API key itself, okay? Another thing we tend to do, unfortunately, is create like what I like to call a master key. Is I've got one API key, and it does everything, has access to everything. Not the best practice on earth. A better practice would be to delegate to multiple keys different responsibilities. So if anybody gains access to one, they have a limited purview into the system and not the entire kingdom, right? So stay away from creating just one key to rule them all idea. Never the best plan. Delegate that out to separate keys. And then there's unused and stale keys that just linger around. Are we doing any kind of key rotation? We should be, because those keys kind of hang out. It's like old user accounts. What are these old user accounts sticking around for? Nobody's logging in with them. No one's using them, but they become a part of the attack surface because anybody that enumerates them now is kind of flying under the radar because You're not expecting it to be used. If there's no reason for it to be, then it's time to get rid of it, or it's time to change it up. Do rotation of keys. So if they are sticking around, make sure that you're rotating them on a scheduled basis. That way they will cease to work if someone had gained access to them previously after X amount of time. It can just help us out. Last thing I'm going to talk about when it comes to APIs is unhardened clients, right? These are the hosts that have access to the keys, have lax security, and therefore they're most likely going to be compromised. And if and when they get compromised, then so that threat actor has access to those keys. So we want to make sure that we harden these hosts, do some whitelisting of things like software, websites, and communication channels, so that the people that are using these devices that access your API have some sort of security on top of them. Because again, it's that layered approach. If I make my device secure, then it's going to be harder for you to gain access to my device, and therefore then gain access to my API, which has access to sensitive stuff. So there you go. There's some API security that we all should be aware of, and the threats that are around them.
I've seen in the news, in some of the feeds that I listened to over the last couple of years, that you always hear about this next one, right? User data, 2 million, users' information was stored in an orphaned, cloud-based service, and now it's been compromised, and they're selling it on the dark web. What am I talking about? But I'm talking about storage. And it's important that we make sure that the storage that we use inside of the cloud is secure. Dan, tell me some of the things that I need to keep in mind.
Yeah, man, I love seeing those headlines that say S3 bucket was open to the world. And
That's right.
Somebody just looked at
it. And thank goodness the one that I read was actually a company that was doing threat intelligence. They weren't the bad guys or gals, if you will.
They discovered their own problem.
Hey, we might need to let you know this. Yeah. Somebody needs to do something about it.
Yeah, that's super helpful. I love the security community because we are kind of a let's help each other out kind of people. And I like
that. And that was this situation.
Yeah, and that's great. The last thing you want to see is threat actor finds PII in open S3 bucket. Never good, right? And there's tools to be able to find those. So unprotected storage, a big deal. Again, open access, probably one of the first and foremost threats is that we put in, it blows my mind, but we do this out of pressure or ease or whatever. We just go, okay, let me grab some storage out of this cloud instance and I'll throw some data in there. And then there we go. And I'm having trouble accessing that. Let me just make it open. Yeah, now it's open. Now I can get that access. I'm making sure everything's working. And then we forget to actually set some sort of access back onto those systems. And there they are, wide open for the world to see. All someone has to do is actually stumble upon them. And now they've got access to that information. So a really big deal that we need to be looking at how we're securing our storage and making sure that there actually is security around storage, nothing just open to the world, giving them access into those systems. Check those permissions, because sometimes defaults will be read-write, right? Maybe it's cool that people are reading that data that's on that cloud storage, but if you didn't check the permissions and they also have write access, well, they can change things, they can add things, use it as their own bucket, start pushing data up in there, right? Don't want that. So check those permissions on the data itself to make sure that it's not read-write permissions on those things. Misconfigured origin settings. This is another big deal. So with the cross-origin resource sharing policies that we use, so if you've got cloud storage and maybe you need to have your clients access that, obviously that's why you set it up. But a lot of times you'll be giving access through a CDN, right? And because of those cross-origin policies, I can say, well, trust that CDN. If it comes from here, that's fine. But a lot of times we don't set up those course policies correctly, and we tend to remove security and make it even easier for people to fake where they came from and therefore get access into that system. So we have to be really careful as we set up our course policies to be as secure as possible. You got to be on the lookout for those types of attacks where I could possibly gain access to that storage system through those lax policies because I'm trying to give more unbridled access through my CDN network. So be aware of those. And don't forget logging and monitoring. It's always a good idea. I'm going to throw that on the pile. If you have logging and monitoring systems in your cloud solutions, you should be using them. They're there for you. Avail yourself of them. It's great products because they're going to help you know when something goes wrong. They're going to help you know if everything's going right. If you're not logging and monitoring, you're just asking for a problem. So set up those alerts. Because we do insufficient logging and monitoring, things go undetected for way too long. I think the average is something like 175 days or something. Yeah. Average data is something in the hundred somethings. I think it kind of shifts around depending on the source you look at. But, 6 months we're looking at here, 3 to 6 months. Do you want a threat actor lurking around inside of your organization for 3 to 6 months? I don't. I know if you're logging and monitoring, there's a good possibility that you would actually detect that the attack was even occurring. Maybe you catch it as it's happening and you shut it off. Or that we pick up some weirdness through checking logs and doing that. So we don't want that. We want to make sure that we always have the ability to access our stuff and that we see a problem as it occurs. So logging and monitoring, make sure that you're doing that, because when you're not doing that, that's basically creating a threat to your cloud service. So there you go, Wes. There's some other cloud services that we might need to be familiarized with and the threats that surround them.
Sure, some of those outlying, things that are in the bucket that we still need to make sure that we are monitoring and watching. So remember just some of the concepts that we've talked about, things like function as a service, otherwise known as serverless architecture, infrastructure as a code. We talked about APIs and paying attention to the security of those too. Key management is so important, so do it properly, as well as things like unprotected storage. And then finally, just having your eyes on what's going on in that infrastructure. We got a lot more to come in the CySa Plus, but we don't have enough time in this episode. We hope you've enjoyed it, and we hope to see you soon.
Thank you for watching IT Pro TV.